Chapter 3, Section 6 is proving lines parallel, and this is basically the opposite or backwards of 3, 5. We're starting with the angles. They tell us some information about the angles, and from the angles being congruent, we can then say that the lines are parallel. So we start with the angles. This first one, these are corresponding angles. So our corresponding angles are congruent, and that makes the lines parallel. Since these angles are congruent, we can then say that M is parallel to N. Converse of the alternate interior angles congruent is AIAP. So these alternate interior angles are congruent. All we know is that the angles are congruent, so we can then say that the lines are parallel. A is parallel to B. Converse of the alternate exterior angle AEA theorem. If alternate exterior angles are congruent, so if 1 is congruent to 4, then we can say that F is parallel to G. Next one, same side interior angles congruent, or I'm sorry, not congruent. This is the one where they are not congruent. We're going to call this SSIAP. If these angles add to 180, then you can say that your lines are parallel. And we have same side exterior. If your same side exterior angles should be right here. This 2 should be right here. So if these same side exterior angles add to 180, then you can say L is parallel to M. And the first thing we are asked to do is find the value of X that makes these lines parallel. 3 and 7 are corresponding angles, so we would want those things to be equal. 4x minus 80 equals 3x minus 50. From there, you subtract 3x from both sides, and that becomes x minus 80 equals negative 50. Adding 80 to both sides, you have x equals 30. If x equals 30, that means these angles are congruent, and then the lines have to be parallel. Letter B, 1 and 8 are alternate exterior angles. So if those alternate exterior angles are congruent, that means the lines are parallel. So we subtract 4x from both sides, and that becomes 25 equals x plus 12. Subtracting 12 from both sides, x equals 13. Letter C, 3 and 2, these angles are not equal. These are same side interior. So these two angles have to add together to get 180. 4x plus x is 5x plus 30 equals 180. From there, you subtract 30 from both sides, and that becomes 5x equals 150. And when you divide both sides by 5, x equals 30. Letter D, 8 and 4 are alternate exterior angles. So 13x minus 4 equals 9x plus 16. Subtracting 9x from both sides, you have 4x minus 4 equals 16. Adding 4 to both sides, you have 4x equals 20. And dividing both sides by 4, x equals 5. Letter E, angle 8 and 5 are same side exterior. So those two things, if you add them together, you get 180 same side exterior angles. So that becomes 8x plus 96 equals 180. From there, you subtract 96 from both sides, and that becomes 8x equals 84. And when you divide both sides by 8, x equals 10.5. Letter F, 1 and 3, these are corresponding angles. So 3x plus 10 plus 6x minus 8. How about not that? How about these are corresponding angles? So 3x plus 10 equals 6x minus 8. From there, you subtract 3x from both sides, and you have 10 equals 3x minus 8. And when you add 8 to both sides, 18 equals 3x. And dividing both sides by 3, x equals 6. Number 2, you just have to state the postulate or theorem that proves the lines are parallel. 1 and 8 are corresponding angles. So if the corresponding angles are congruent, we start with the angles, then the lines are parallel. B, if these two things add to 180, those are same side exterior angles. If those two things add to 180, then the lines are parallel. So I guess I should put a P on the end of that. Letter C, 1 and 6 are alternate exterior angles that are congruent, and that makes the lines parallel. Over here, angle 2 is congruent to angle 7. Those are alternate interior angles congruent, so the lines are parallel. E, 4 and 7, those same side interior angles add to 180, so that makes the lines parallel. 1 and 6, those are same side exterior angles that add to 180, so that makes the lines parallel. We have 2 more of these at the top of the next page. 3 and 7 are alternate interior angles. We started with the angles, and that makes the lines parallel. H 8 and 5 adding to 180. Those are same side exterior angles that are congruent, that add to 180. So our lines are parallel. And letter I, 4 and 8. Those are alternate exterior angles that are congruent. So that makes our lines parallel. Letter J, and sometimes for this it helps to cover up parts. 4 and 5, if we cover up that, those two things add to 180. Those are same side interior angles, which make the lines parallel. 4 and 8, those alternate interior angles are congruent, so the lines are parallel. Next one, I'm going to cover up this piece. 2 and 4 are corresponding angles that are congruent, so they make the lines parallel. Letter M, 1 and 9, and if you want to cover up that, that's fine. 1 and 9 are alternate exterior angles that are congruent, and they make the lines parallel. 7 and 12 are same side exterior angles. They add to 180, so the lines are parallel. This first proof can be either 4 or 5 steps, depending upon which angles you choose. So we are given A is parallel to C, and angle 4 is congruent to angle 3 for our given. And I'm going to mark up the picture. Those two things are equal. And our goal is to get these two lines parallel. So we need to get some angles congruent. Well, if A and C, we know those are parallel, we can then say that angle 4 is congruent to angle 2, because we started with the parallel lines. They told us these lines were parallel, so those corresponding angles are congruent. Well, we know 4 is congruent to 3. 4 is also congruent to 2. So we can say 2 is congruent to 3 by everybody's favorite reason, substitution. Well, now if we have angle 2 right here, congruent to angle 3, we can then make a conclusion about those lines. Since 2 is congruent to 3, we can say A is parallel to B, because we have these corresponding angles congruent. We just got these angles congruent. Since the corresponding angles are congruent, then we can say the lines are parallel. And there's another way you can do that with 5 steps, and we did it in 4. Proof B, we are given L is parallel to M. So just looking at that, if L is parallel to M, and I'm going to cover up this bottom half, if L and M are parallel, I can say something about these angles. We can say angle 1 is congruent to angle 2, because they told us, we were given those lines are parallel, and we said those alternate exterior angles are congruent. Well, once I wrote down this parallel and got those angles, I kind of forgot about this other part, which is our given. Well, we have 1 congruent to 3, and 1 is congruent to 2. So those two are equal, and these two are equal. So we can then say 2 is congruent to 3, by substitution. And now, since we have these angles congruent, we know that these two are equal. We can then say that R is parallel to P because we had the corresponding angles congruent, and that made the lines parallel. Letter C, we have A is parallel to B. And again, right here, right now, I'm going to say something. If A and B are parallel, we can say these are congruent. We can say angle 1 is congruent to angle 2 because we were given the parallel lines. And we can say alternate exterior angles are congruent. And I should fill in the rest of my given. 1 is congruent to 3. We just figured 1 is congruent to 2. So now we can say 2 is congruent to 3 by substitution. And since these two are congruent, we can guarantee that L is parallel to M. And that's because we had alternate interior angles congruent. The angles are congruent, so that made the lines parallel.